Hi, my name is Autumn McSwain, and this is my Physics 2 Lab 1 charge tapes report. So, the purpose of this lab was to utilize two pieces of charge tape to determine how they interact with the environment and how much excess charge was on one of the pieces of tape. In this lab, it will be determined that the clear tape had a positive net charge of 1.11 e to the negative 8 coulombs, and the tape is deficient of 6.94 e to the 10 electrons. So some key concepts before getting started is Newton's second law, which states that force on an object equals the rate of change of its momentum with respect to time. And this is used to create the velocity update formula as well as the position update formula, which are both shown below with position update on the left and velocity update on the right. Two more important key concepts are gravitational force near Earth's surface, as well as the electric force law or Coulomb's law. So the gravitational force near Earth's surface is given to be a value of negative 9.8 meters per second squared. This can be used as F net and it only acts in the y direction, which is why it is given in the vector 0, negative, and g0. For Coulomb's law, this is the force of attraction or repulsion between two charged bodies is directly proportional to the product of their charges and inversely proportional to the square of the distance between them. This is what Coulomb's constant states, or this is why Coulomb's constant is 9 times 10 to the 9th, and this formula is Fe equals Coulomb's constant times Q1 times Q2 divided by R squared. And these can be absolute value to get Fe absolute value, or instead of Q1 and Q2 being absolute valued, as well as R being absolute value, you can multiply by the unit vector R. So some assumptions were needed before starting this lab, and it was that the tape would be taken as a point charge, and that would locate the center of the tape, and it would be represented as a singular point charge. Air resistance would also be ignored, and both of the tapes would be assumed to have the same amount of charge. So the procedure of this was first we had to create a U-tape, which was created by placing one tape on a table and taping another piece of tape on top of the first tape. This is done twice to create two U-tapes. The U-tapes were then removed from the base tape. We then observed how the two U-tapes would interact with each other. I then observed the interaction between the U-tape and a charged plastic object, which my charged plastic object was a pin that I had rubbed on fabric. The fifth part of the procedure was to suspend one U-tape on objects of equal height, and then place the other U-tape below the suspended U-tape and observe the motion of the suspended U-tape. This is shown in the diagram to the right on the bottom, and the top one shows the U-tape versus the base tape. And that was a procedure for the actual experiment. So some notes from the experiment is that the tape B suspended was the system, and the surroundings were the held tape and the gravity. The tape was about 0.18 meters long and 0.0198 meters wide. The weight of one piece of tape is 0.001764 newtons. The interaction between the suspended U-tape and the other U-tape was repulsion, and this was given at a distance of about 0.025 meters. The force of gravity on the U-tape was negative 0.001764 newtons in the y direction. This will be the same as the magnitude of the electrical force. And the deficit of electrons of about 6.94 e to the 10 electrons. So this was all of my experimental data. Now we get into the coding. The coding takes part in two places, one as a point charge and then one as a line charge. So the constants are shown on the left. These constants will basically be the same throughout the whole thing. And then for the point charge, all I needed was the gravitational force and the electric force, which are shown here by how Fg is the negative weight in the y direction, and then Fe is just the positive weight going up. So the force of gravity will act downwards, and the force of the electricity will work upwards. And this will create my point charge, and it will roughly show how the two are interacting. And then the other coding is to demonstrate it as a line charge. Now, this is important because this makes the tape as a line of charges rather than a single charge. So this will create a different type of charge on the thing. So to start with, we had to basically do what we did before, where we put out the constants and then we find the E field and everything. But what's different is that we're solving for dq top on top tape, and we're solving for dq bottom and bottom tape. So we are solving for both the top and bottom tape and how they are charged and how they will interact with each other. But gravity and the electrical force will still go in the same direction, just the electrical force will have a different charge because there will be more charges on there, which is shown here. The top one is my point charge graph, where you can see gravity is working down and the electrical force is working upwards. The same thing is happening in the other one, however, it is a line of charges instead of just a dot. And through this, the magnitude of the gravitational force on the top tape is 0.001764. The magnitude of the electrical force is 1.764 times 10 to the negative third. The charge of the tape is 1.106 e to the negative 8, and the number of deficient atoms is given. And that was my discovery in the coding. So as far as the discussion goes, since the tape is positively charged, there is an electron deficit. For the suspended U-tape to float, the net force must be equal to 0 because we're at static equilibrium. This means that the force due to gravity will be equal to the magnitude of the electrical force, as stated earlier by how the force of gravity and the electrical force are basically the same. Some error for this is that the tape length and width might not be totally right. The separation distance may not also be entirely correct. Another issue was I had a hard time holding the U-tape perfectly parallel. I kind of tended to tilt it, and there was probably also errors in rounding. So for my what ifs, if the signs of the charges were reversed, what would change about the observation made with the tape and other charged objects? If the charges were to switch, the electrical field would change because the field would point towards the tape instead of away. However, the observations themselves would not change because the pieces of tape would still have the same charge, which would force them to repel, and the pin cap and the tape would still have opposite charges, which would force them to attract. Why are the two computational models values for Q different? Which value is more likely to be closer to the real value and why? The two models are different because one is a line charge while the other is a point charge. This causes the line charge to be more accurate because it takes into account the length of the tape. This means that the Q value for the line tape will be more accurate because it more accurately represents what happened in real life because we used a piece of tape instead of just like a square of tape. And that is my report for lab 2. Thank you.